Hello there. I want to welcome you all to this class and also to congratulate you for taking that bold step and having the passion to learn about live sound. This is the first class in this course, and I hope that we are going to have a good time. We are going to learn. It's going to be an interactive session. It's more of practical, but today we are going to learn about theory. One thing I believe about sound, it's usually practical, but it's more of theory. Anytime you're going to troubleshoot or do anything that concerns sound, it's the theory that is going to help you. So today it's not a big class or a complicated class as such, since it's our first class, and we are going to define words that are usually heard or used in live sound. I'm sure in one instance or another you've experienced live sound in your houses of worship, in any kind of event that you've attended. You've experienced live sound, and that is what live sound is all about. So today we are going to define, in the next two classes, we are going to talk about words that are mostly used in live sound. And then from there we are going to do the theory of live sound. And then we are going to do the practicals and learn now where everything is being applied and the use of each and every equipment. Thank you so much for joining me, and we've just introduced ourselves, and we are going to form a family and have an amazing time in this class. So as I said, the topic is live sound introduction and theory, and today we are going to do the introduction part, whereby we are going to define the commonly used words in live sound. These are not the only words used in live sound, or maybe kind of the complicated words used in live sound. We have so many words, and some of them we are also going to learn them as we go by. So if you've not heard a word from this class or the next class, and you've heard it before, be sure we are going to mention it even in our after classes. So the first word you're going to define is the amplifier. This one is a common word used in sound, especially in live sound. And an amplifier is usually the last equipment before the speaker. An amplifier boosts the electrical signal in the audio so that they can be used by a loudspeaker to generate acoustic energy. So it is usually the last equipment before the speaker. Before you set up the speaker, you first set up the amplifier, and that equipment is usually called the amplifier. So what we mean by boosting the electrical signal in the audio to acoustic energy is that the signal that is usually in the equipment or in your equipment is electrical, and the signal that you hear is the acoustic energy. So that acoustic, whatever signal goes to the loudspeaker is not enough, before the amplifier, is not enough for the speaker to work or for the speaker to function. So the work of an amplifier is usually to boost that signal, the electrical signal. And then now when it is boosted, the speaker can interpret the signal, and hence now producing the acoustic energy. So the next word we are going to define is the auxiliary. You're going to hear about auxiliary so many times, and this term is often used to describe secondary output channels. Now we have the main output channels, which is the stereo, main, left and right, and then we have other outputs. So those outputs, we usually call them the auxiliary outputs. In other consoles, they are going to be called the mixed outputs. But generally, when someone tells you an auxiliary output, what they mean is the secondary outputs. So stage monitors, broadcast, or other devices other than the main loudspeakers are usually connected to auxiliary channels. So auxiliaries are just outputs that are secondary from the main stereo outputs. So the next thing we are going to define is the channel strip. And this is a group of controls in an input or an output of a console. So the first thing that you're going to meet when you input a microphone or anything else is a channel strip. A channel strip is where you have controls like the gain, EQ, pan, fader, effects. It's where the strip of that channel where the signal flows for that specific channel. Now a channel strip can be inputs or outputs. So it can be used for either inputs or outputs. So the next thing that you're going to define is the compression. So this affects the dynamics of an audio signal. The compressor averages the level between the high volume and the low volume signals. So what this means is that we have the high volume and we have the low volume signals. So what a compressor does, number one function of the compressor is that if you have a loud signal and you don't have, of course you don't have the time to go to each input channel or input strip to reduce the channel anytime it goes beyond the nominal signal. So what the compressor does, anytime the signal goes above the nominal signal, the compressor presses it down. So it reduces the clipping or the peaking of the signal. Now when it goes down, the compressor does not stop there. So we also have the lowest signal. Now the lowest signal, the importance of the lowest signal is that sometimes the noise signal might be too much compared to the signal. And of course, when you're setting up sound, you want the signal to be more than the noise. Now what the compressor does, it has compressed the highest signal. Now with the lowest signal, it also takes, for example, this is our channel, it takes this is our signal, it takes the signal and then boosts it up. Now what happens is that now our signal goes beyond the noise signal. Now you have a signal that is not clipping and that is beyond the noise signal. And now that's a clean signal. So that's the work of a compression. Of course, we are going to go deep into that when we learn about compression as a subtopic. The next thing is the crossover. Now this is a device that takes in an audio input and separates the full frequency range into two or more smaller ranges. What does this mean? When I have a frequency range, or maybe when I have an audio signal, it usually has a full frequency range. When I say a full frequency range, I mean that it has the lows, mids, and the highs. That's a full frequency range. Now, there are speakers that will not produce the lows. There are speakers that will not produce the highs. So a crossover separates those signals that are needed in a specific loudspeaker. For example, I have a loudspeaker or a subwoofer that produces only signals below 80 Hertz. Now a crossover will separate your signal and it will send, according to how you have set it, it will send the signal to the subwoofer. Anything that is below 80 Hertz will be sent to the subwoofer. For example, you have a tweeter and it does not take anything less than 10 kilohertz. So the crossover will take the 10 kilohertz and send it to the tweeter. So that is the function of the crossover. And most loudspeakers cannot handle the full range, as we've talked about, of audible frequencies. So an audio crossover is used to provide high and low high and mid low high frequency information to an appropriate loudspeaker. So the next thing we are going to talk about is the decibel. Now we cannot go too far in live sound or in audio without talking about the decibel. And this is usually defined as the unit of measure that we use to describe and measure the intensity of sound or other electrical signals. Changes in volumes, sound pressure are expressed in terms of dB. So dB is usually the decibel. Something else we are going to define is the digital signal processor. So digital signal processors take an analog audio signal and convert that signal into digital audio, which can be manipulated with various digital utilities like EQ, compression, etc. So DSPs, as we usually call them, come in various formats for different purposes. Some are single device dedicated to a single function. Some perform multiple functions. So a DSP, you can buy a DSP that performs one function, maybe the EQ, it only does EQ. And you can buy a DSP that has the crossover, it has the EQ, it has the effects. It's up to you. But that is generally an audio signal processor. So the next one we are going to define is a driver. And a driver is the term used to describe the physical loudspeaker element that converts electrical energy to acoustic energy. We say that anytime you want to hear sound, you cannot hear sound in terms of electrical energy. And like now when I'm talking, sounds usually start as acoustic energy. Acoustic energy is energy that travels through a medium. Now a medium is like air, liquid, and solid. Now when it gets in audio equipment, it doesn't come in as acoustic energy. It's usually converted to electrical energy. And now we are going to get to that, but maybe to take us through, now the microphone is the equipment that now converts from acoustic energy to electrical energy, so that now it can be interpreted in audio equipment. After it travels through all the equipments, the loudspeaker now converts from electrical energy to back to acoustic energy. But now the energy is more defined, it's louder, it's more processed. And now when we talk about the driver or loudspeaker, it is that equipment that turns or converts electrical energy back to acoustic energy, so that now it can be heard. So all loudspeakers contain drivers. Most woofers will have a large magnet and a paper or plastic diaphragm, while tweeters will have smaller magnet and a dome or cone diaphragm. So when you talk about drivers, we are specifically talking about loudspeakers. And that is the function of the loudspeaker, to convert from electrical energy back to acoustic energy that can be heard by our ears now. So the next thing that you are going to define is equalization. Mostly you're going to hear it being called EQ. So this is a term we use to balance among various audible frequencies. Think of EQ as a volume control for specific frequencies or a frequency range. Now, for sound to be defined as sound, it has to be between 20 Hertz to 20,000 Hertz. So 20 Hertz, we are going later to define frequency, but Hertz is what is the SI unit for frequency. Now frequency, for it to be classified as sound in human beings, it has to start from 20 Hertz to 20,000 Hertz. Now in animals like dogs and cats, it usually goes to 45,000 Hertz. But a human being cannot hear anything beyond 20,000 Hertz. So that is what you usually define as frequency in human beings. Now equalization is the balance of the frequencies. Each frequency has its function. Generally speaking, frequencies can be defined as highs, mids, lows, low mids, high mids, etc., etc. So now EQ, it can also be defined as the volume control for a specific frequency. For example, if I want to add maybe 2000 Hertz, if I increase the EQ for 2000 Hertz, it means that I'm increasing the volume of 2000 Hertz. If I decrease 2000 Hertz, it simply means that I'm decreasing 2000 Hertz in that frequency range. So that is equalization. The next thing that we are going to define is the fader. Now a fader is the slide control often used to control the final audio signal of the input and output channels of the console. So in the beginning of this class, we talked about channel strip. And we said that the topmost knob in a channel strip is usually the gain or the stream. Now the bottommost knob in that channel strip is usually the fader. So it can be a knob or it can be a slide. So but the bottommost part or knob of the channel strip is what we call the fader. Now the fader is usually used to add or decrease the audio signal. And it's what is usually most people use for volume. But for the next equipment in our audio signal, maybe, for example, we are talking about the mixer or the console. The next equipment in our audio signal, the fader acts as the gain. And so you must be careful when you're operating the fader. And we are going to talk about the fader later as we talk about the console and discuss in details about the console. The next thing we are going to define is the frequency, and we've already talked about it. But generally, we can define frequency as vibrations in the air that create sound. Now, for sound to be classified as sound, there must be vibrations. And those vibrations must occur in a medium. Now, sound has to occur in the air. And now these vibrations are what we are calling frequencies. And it is the number of cycles per second that a vibration occurs or forms a wave. Now, frequencies, the cycles or the vibrations, they have to be per second for it to be one cycle. And now, when we talked about a human being hearing from 20 hertz, what we meant is those are 20 cycles per second. When you talk about 20,000 hertz, those are 20,000 cycles per second. And that simply means that's 20 hertz to 20,000 is the frequencies. So frequency is the number of cycles per second. The next thing we are going to define is the front of house. So this term describes anything that is happening in the listening audience and controlled by the main console. Now, when you're setting up sound, there is the stage and then there is the audience area. Now, anything that happens for the audience is what is usually called the front of house. Now, we have the speakers set for the audience. Those are front of house speakers. We have an engineer that sits with the audience. That's the front of house engineer. Anything that is set for the benefit of the audience is what we are calling the front of house. So anytime we are talking about engineers, anytime we are talking about equipment or speakers being set, we are going to use this word a lot. So the next thing we are going to learn about is gain, or to define is gain. Now, this term refers to the very first stage of audio signal amplification. So we talked about our channel strip, and we said that the topmost knob in our channel strip is usually the gain. Now, what does the gain do? And we just defined that it is the first stage of audio signal amplification. So what that means is that some mixers or some consoles, we call the gain the trim. Some will call it the preamp. Now, when you talk about audio signal amplification, so that's where the word preamp comes from. It means that this is the amplifier before the main amplifier. So we define the amplifier and we said it is usually the first equipment before the loudspeaker, and it's usually to convert electrical energy to acoustic energy. Also, it converts line level signal to speaker level signal. Now, we have 3 levels of signals in sound. It starts with the mic level, then it goes to the line level, and then it goes to the speaker level. Now, anytime this sound comes in the microphone, it's usually the mic level, and it's usually the low voltage signal. Now, no equipment in sound can be able to interpret the mic level. So for the equipment to be able to translate the audio signal, it has to be in line level. Now, what does the gain do? Since it's the first knob in the mixer or in the console, it converts mic level, or it increases mic level to line level signal, so that now it can be interpreted as sound in equipment. So most people will use the gain as volume, but that's a big mistake. Gain is not for the volume, but the results will be an increase in volume. But that is just a voltage increase, and it is an increase in level from one level to another. So gain will allow you to adjust the sensitivity of the signal where it enters a device. A console has the gain knob at the top of each vertical channel strip. So we're also going to learn about gain structure. Gain structure, we've just defined the gain knob, but there are different gain knobs in each equipment. So from the top to the last, that is what we usually call the gain structure or the gain staging, and we are going to learn about that in our classes later. So the other thing we are going to define is the headroom, and this one refers to the buffer that is available between the nominal audio signal level and the maximum signal level capacity of the equipment. It allows for a greater dynamic range of the audio signal before it clips beyond the capacity of the device. So now we have a nominal audio signal, and then we have a point where now the signal starts to distort or to clip or to peak. Now the gap between the nominal and the clipping signal is what we are calling the headroom. And it is very important, especially when you have a mix that you are working on, so that every signal is enough for the equipment to interpret, and also it does not reach the clipping point. So the distance or the gap between that nominal signal to the clipping level is what we are calling the headroom. So to move on to the next one is the impedance. So this refers to the effective resistance of electrical signals found in sound systems. Now, when you're working in live sound, you're going to be working with different sound equipments. And it is very important to understand the impedance of every equipment, because that is how the equipment relates to each other. If the impedance does not match, that is where trouble occurs. A speaker blows out or something bad happens, maybe your equipment catches fire. It is because the equipment does not match the impedance. And we usually think of impedance as a friction in an electrical circuit. It's like friction. How are those equipment relating to each other? It's very important to understand, especially when you're buying your speakers and your amplifiers. One of the most important things to look at is the impedance of both equipments. So all sound system electronics and devices have an impedance characteristic that plays a crucial role in how they interact with other system components. So maybe to add, impedance is usually measured in ohms, and the sign for ohms is usually an omega. So anytime you come across an omega sign in live sound, that is impedance. That is what we are talking about. So the next we are going to define is the line level. And when we are defining, or we are talking about the different levels of audio signal in live sound, we mentioned the line level, whereby it's a level that is converted by the gain in a console, so that the equipment can be able to define your audio signal. And this is usually a high impedance signal, just as we've talked about impedance previously. So we're also going to define a loudspeaker, and this is the component that converts amplified electrical energy back to acoustical energy that we hear. And we also talked about that when we were defining what is a driver. And driver is specifically what is found inside a loudspeaker. But now a loudspeaker is now the component that converts that electrical signal back to acoustic energy. Because the main reason is we cannot hear electrical energy. That is energy to be interpreted by equipment. And then the equipment cannot interpret the acoustic energy. So sound has to be converted from acoustic to electrical and then back to acoustic, so that now we can hear. And then now it comes back as electrified energy now. That is the function of the loudspeaker. So the next one is the mic level. We've talked about that, and this is the type of signal that comes from a microphone, and this refers to low impedance signal, and that is why it has to be converted to line level, because it's usually too low. So it has to be converted. So we're also going to define a microphone. Microphones capture acoustic energy and convert it to electrical energy that can be transmitted through the sound system. That is what we've just talked about, converting acoustical energy to electrical energy that can be transmitted through the sound system or translated by the sound system equipment. The next one is monitor. This one refers to a stage monitor loudspeaker that is used to allow musicians, presenters, and performers on stage to hear themselves and others. So a monitor is also a loudspeaker, and it's specifically, we talked about front of house, and we said front of house is the speakers or anything that are involved with the audience, whether they are the speakers, they are front of house speakers, whether it's the sound technician, it's the front of house engineer. Now we have the monitor. And the monitor are loudspeakers that are usually on stage to be used by the musicians to hear themselves. Since the front of house speakers are facing the audience, we also have other speakers that are facing the musicians, performers, or presenters. And those are called the monitor speakers. Now we also have the monitor sound engineer, and that is the sound engineer who operates the monitor speakers or anything that is happening in front of the stage. So we also have something else called the in-ear monitors. The function is the same, but now these ones act as maybe headphones or earphones that are worn by the musicians or performers, and they are used to replace the loudspeakers. So instead of having the speakers facing the musicians, now we have them, they have the earphones or the headphones. So they are just the same, but monitors, they are usually anything that is used to refer or just to help the performers to hear themselves and maybe to hear others also. So the next thing we are going to talk about is pan. The pan knob on the console is used to adjust stereo audio from left and right. Now we have audio that comes in as stereo, and it is the work of the sound technician to determine whether it's going to be stereo or mono, and we are going also to define those words later on. And the pan is what now takes an audio signal either to the left or to the right. It's very important because we also have 2 ears. So sound is usually produced or given as stereo. So the pan knob is what defines the stereo or mono, or how it's going to be, the sound signals are going to be sent. So that knob is the one that you usually take either to the right or to the left according to your preferences. So the next thing you're going to define is the phantom power. So condenser microphones and other active audio equipment need additional power to function properly. This power is often from a console or other power supply and is called the phantom power. Now the condenser microphones are made in such a way that they need an extra power for them to perform or for them to function. And this power is what we call phantom power. Now phantom power is usually 48 volts. And that is what is needed. Now that phantom power can be produced by the console, and if not the console, it can be produced by other power supply equipment. You can find them in a DI box, or maybe something else, or maybe a guitar effects, or something else. But there are equipment that cannot function without an extra power, and that is usually called the phantom power. The next thing we are going to define is the pre and post. These are commonly used words in live sound, but less understood. But they are very easy. So pre refers to the pre-fader level, meaning the audio signal level that is available after the fader level adjustment. Now we said we have the main outputs and we have the auxiliary outputs. If you want to operate your auxiliary outputs and they are not going to be defined by the main fader, that is pre. It means after the fader level adjustment. So post is the fader level, meaning the audio signal level that is available after the fader level. I mean, the pre is before the fader level, and the post is after the fader level. For example, I want to set my monitors in one of the auxiliaries. So the level of the front of house is not what is going to define the level of the monitors. So the monitors should be at pre, meaning it's before the fader, meaning the fader does not affect what goes or comes out of the auxiliary output for the monitors. So that is one instance where we use the pre-fader output. Now the post, one of the instances is For example, we have an outboard processor that is an effects or a reverb or a delay. Now we cannot set our effects at pre because you might reduce the volume of the speaker and the effects remain, and that should not be the case. So we usually set the effects as posts because we want, as we reduce the level of the speaker, the effects reduce. As we increase, the effects increase. So those are instances where we use pre and post. There are many other instances that we are also going to talk about, but for the sake of our definition, I think that example helps. So the next thing we are going to define is the preamp, and we've used the word preamp before. This takes the initial audio signal and boosts it slightly so that it can be used in other audio equipments. Gain controls the preamp so that an audio signal can be properly adjusted for your needs. So we said that we usually have different amplifiers in our audio signal, and we talked about the amplifier that is before the loudspeaker. So we also have a preamp, and that is usually in the gain control. So we say that it's called the preamp because it's an amplifier that is before the main amplifier. And it's usually used to convert the mic level to line level. So it's usually a gain knob control, but the system itself or the circuitry itself is what we are calling the preamp. So we're also going to define the signal. By now we've talked a lot and mentioned a lot about a signal. So this describes to electrical information that is transferred from one audio component to another. So when we say that it is electrical information that is transferred from one audio component to another, that simply tells you that what you hear with your ears is not a signal. That is usually a wave. And what you produce maybe while speaking is not a signal. Because from the definition, a signal is an electrical information. And we said earlier that our ears are not made in a way that they can hear electrical information. But audio signals are made in a way that they hear audio components are made in a way that they can hear electrical information. So anytime sound enters equipment or an equipment, from there it's where it's called a signal. When it leaves a loudspeaker, it's not a signal, and now it's acoustic energy. So signal is, we call it an audio signal when it's inside the audio components. So please note that. Then we are going to define the signal path or signal chain, and this refers to the route that an audio signal takes on its way through the sound system. A signal may pass through many components. Each of these components is part of the signal path. Now, when sound enters a microphone, it's usually converted from acoustic to electrical. When it's converted to electrical, now it's a signal. When it travels all through the equipments from mic to the console to the EQ, crossover, effects, and everything to the amplifier, before it's converted to acoustic energy, now that route that has been followed by that signal is what we are calling the signal path or the signal chain. Now we are going to talk about the signal path or the signal chain later on, and we are going to see the importance of that, especially when you're troubleshooting. Now your sound has gone off. There is no way you're going to troubleshoot that unless you know the signal path of your signal. So we are going to talk about that later on, but for now, we are just going to define it as the route that an audio signal takes on its way through the sound system. So with that, we've come to the end of this class, and as I said earlier, these are not the words or all the words that are usually used in audio or in live sound. And as we go by, we are going to use more other words in live sound. And at the moment, I'm going to invite any question, and let's have a conversation about what we've discussed in case you've not understood anything or you want more clarification or anything. Otherwise, thank you for joining me in this class today, And also, once again, I want to congratulate you for taking that bold step and having the passion to learn about live sound. Thank you so much, and see you next time.